Hey everyone, it's great to be here. There's so many people here. This is really awesome. As Ali mentioned, I'm going to talk about our experience with customers going into production with language model applications and the infrastructure we're building to support those. It's been a completely crazy 12 months for us in seeing LLM and generative AI workloads on Databricks. I pulled some numbers. These are from yesterday. I pulled these. In the last 30 days, more than 1,500 customers have used a transformer model on Databricks. That's the underlying technology behind language models and generative AI. And our usage of GPUs on the platform is growing 25% month over month right now. That's by far the fastest growth rate we've ever seen for an infrastructure component on Databricks. So it's nuts. It's exciting. And we're spending time working with hundreds of these customers to build real applications beyond demos and deploy those in their businesses. This is an example of a few customers we're working with. I'll just mention a few. So Block on the top right, you may know them as Square. They're building a generative AI app for their internal customer support agents to help them more quickly resolve information, get more information that helps them satisfy their customers. JetBlue is a use case that's actually going to be discussed after me, so I'm not going to give that one away. Maybe I'll choose one more. So Vizio here at the bottom, that's a TV company. They have these voice remotes. You can talk into your voice remotes. Well, they love to turn those into personal assistants that can do a lot of different things for me on my TV. I'm already sitting there with my remote. So there's tons of excitement and tons of applications. And these conversations all start in the same place. They all start with a business coming to us and saying, I'm super excited. I'm a little nervous. There's transformational changes happening in our industry. There's a foundational change in technology. And how can we compete in this world? And even how can we win? How can we use this to get ahead in our market? And I always tell them the same thing. I say, I have really good news and bad news for you. And they're kind of the same thing. So the good news is that the modeling techniques, the ability to build these models are commoditizing very, very quickly. And I think that's net really good. When GPT 3.5 came out and we saw ChatGPT, a lot of people thought, oh man, this is like complete rocket science. No one will ever be able to replicate this. But 12 months later, in the proprietary model world, there's fierce competition. Prices have come down 10x. There's Google in the market. There's many others building actually quite good chat models. And even more impressively, the open source models have actually gotten pretty good. The research community is getting together. They're sharing the techniques. They're quickly catching up. And for many enterprise use cases, the open source models are very quickly approaching sort of acceptable quality for the foundation models, as Naveen just told you. So the bad news is that you get all this, but all your competitors get it too. So the model itself, the techniques of the modeling itself, is a necessary condition to compete, but it's not really a sufficient condition to differentiate yourself in the market. And I think I'm probably the 5th person to say this today, but I'll give you a little quiz to the audience. The main way that you can differentiate is take advantage of your... OK, I'm going to try that one more time. The main way that you can differentiate is take advantage of your data. Yes, exactly. Your data is hard to compete with. Your data is differentiated. So the game you need to play in generative AI is to really take advantage of the data that only you have to build great applications. And the good news is that generative AI, in my mind, finally allows you to unlock huge amounts of proprietary data you have sitting inside of your organization. So it will ultimately, I think, let companies really jump ahead in ways they couldn't before. But you need to think hard about how you're going to leverage your data. And as a result, the data needs to be at the center of your AI strategy. And this is actually something at Databricks we've really believed in for a long time, even in prior generations of ML technologies. And the way we've accomplished that is something we call Lakehouse AI. And what does that mean? It's a marketing term. But what it really means is that the core pieces of building LLM-based applications, or any generative AI application, is 3 things. It's like preparing your data for ML, so starting with really good data and preparing it in the right format to work with ML models. It's finding and tuning really good models. And then it's deploying and serving applications. That's kind of the development lifecycle for building real ML apps. And we believe that the best way to architect your platform is to do all 3 of those inside of your data platform. Not as a separate system, not as 3 separate systems, but do it with your data. And the reason is that the hardest part of each of these steps is the data part. It's collecting really large data sets. It's integrating data with your models. It's using data to observe the quality and monitoring your models in production. And we think you should do that in your data platform with the same access control model, the same data model, the same governance model, the same UIs, and so forth. So what we've done in the last year at Databricks is we've focused on updating all the key parts of our Lakehouse AI platform to work better with generative AI. There's a lot of similarities compared to conventional AI when it comes to building applications, but there's actually some very key differences too. So you'll hear a lot about these at the conference. I don't even have time to go in depth into all of them, but I'm going to tease and give you a little bit of a flavor of some of the new technologies we're releasing as part of the Lakehouse AI stack. So the first part is preparing your data. And we're super excited to announce 2 new technologies today that will be released in the coming months. The first is a native vector search capability for your document or unstructured data in Databricks. Thank you. And I'll explain a little bit more about what that is in a second. Then the other people can clap. The second is an online support for online feature serving inside of Databricks. Let me talk a little bit about what these exactly mean. They both involve taking data that you have and preparing it for use in online and real-time applications for language models. Vector search is a way to embed document-style data. So this is maybe internal business processes or documentation about how things are done in your company. If you want to hand that to a language model and retrieve relevant documents, the canonical way to do this today is to embed those in a vector space and then do a search in order to get them at the end. I'll show an example to make it a little bit more clear. And feature serving is actually very similar. It's about taking this, in this case, very structured data that you're explicitly deriving, and then making it available online for applications. So let me give you just a quick example to explain what these 2 things really mean. And the example I'm going to use is a customer support bot. So this is a generic company that has a support bot. And in this case, the customers come up and said, I guess they're a little grumpy, and they said, I like to return my last order. So if you just take this and you send it directly to a generic model or to OpenAI or whatever, it's not going to know how to answer that question, right? It's going to say, I don't understand. What are you talking about? So what you need to do is enrich this particular request with data that's specific to your company. So a common architecture we see is that your application will retrieve some information it thinks is relevant. In this example, it might go to your online feature store and ask about this particular customer. Hey, do you have any recent transactions or recent orders from this person? And then it might also go to your vector search engine and look for articles or internal documents about how returns are handled in your company. It'll get that data and then send it to a language model. And that language model, those models are actually powerful enough to take that data and generate a meaningful response. So in this case, it says, oh, you know what? Since your order was placed in the last 30 minutes, I can cancel it for you. Would you like me to cancel it? So the way it was able to learn all that context, it was able to learn that the order was recent, and then it was able to learn that you have a policy for recent orders, was by infusing the context you have from your business. So this is a very, very common pattern we see when developing applications. So I kind of skipped over one part. On the right side, we have this thing, large language model. Now that model is like the brain of the whole application. And you've heard a lot of discussions today about getting good models, building those models. We've also updated our stack in many ways to help you find, tune, and customize those language models, which play a really important part in the end-to-end application. So it goes without saying that there's great proprietary models out there, and their prices are going down. So at Databricks, we've partnered with many of these companies to provide built-in support. We handle credential management. We handle a bunch of other stuff for interacting with these proprietary models. And a lot of our customers start here because these are really good quality models in many cases. But surprisingly, when we see customers going into production, it's very common that part or all of their stack also involves an open source model, because the quality of open source models is getting good and because they're much more tunable and extensible. So this graph shows the percentage of customers, that same set in the last, 30 days, that are using open source versus proprietary models. And it can be more than 100 because many of them are trying both. But as you see, a lot are using open source. In fact, it's actually slightly more than are using proprietary models, but most customers are trying both. So to help with the open source models, Databricks is announcing an open source model library. We've done all the hard work of taking what we believe are the best of breed models in many different areas, things like general language models, but also embeddings or code generation. We've packaged them, made them available inside of Databricks, and we've also optimized them all the way to serving. Now, someone's really excited over there about this. Now, the real win in open source models is customizability. So in the coming quarters, we're going to be releasing many ways to take those open models and customize them to your enterprise use case. There's a bunch of ways of customizing these models. A very popular one is fine-tuning with additional data. So for instance, your support model, you may have 1,000 support interactions that you already know are good. You've had someone look through and say, yes, they answered these questions in the correct way. We're going to make it super easy for you to customize and tune that model with those interactions so that it can do an even better job. We're also going to support things like tuning, performance, cost, and latency trade-offs for these models. So that's getting your models and tuning them, but evaluation is really important too. These models spit out answers, and they're very hard to evaluate compared to more simple types of machine learning because the evaluation criteria are very nuanced. You want the answer to be correct, you want it to be helpful, you want it to not be biased. So we're releasing in MLFlow. For those who don't know, MLFlow is a very popular open source machine learning framework that includes quite a lot of experimentation features. And we're revamping MLFlow to better support language models, starting with an evaluation framework. This lets you compare multiple models against each other and literally A/B test them and observe responses, say which ones are doing better and worse. This is very useful if you're, let's say, comparing a proprietary model to a SAS model or a tuned model to a not tuned model. And we're also releasing the MLFlow AI Gateway, which is totally open source. It's available in Databricks as well. And this is letting you, in your company, instead of every single team setting up an account with OpenAI and setting up an account with Bard and fine-tuning this model and serving that model, you can have all your AI use cases go through one gateway and centrally manage things like credentials, rate limiting, caching, and then you can manage the models as an administrative team and even experiment, A/B test, and so forth across them. So you've got your data. You've got your models. Now the hard part begins, which is going all the way to production. There's kind of two hard things in production. The first is online serving. So what does serving mean? It means you have to have machines running that are hosting your application all the time. If they go down or fail, your application is halted. You need to monitor them and make sure it's working. And Databricks has actually had an ML inference offering for 2 years now. The growth has been really impressive. And we're super excited to announce today that we are adding GPU support in our inference offering. And we're also specifically tuning and optimizing the most popular LLM families out there. So you can have a private copy of these models with high reliability and high performance at serving time. So we plan to keep, as newer models come out, optimizing. We have a whole team that's doing that. And we're super excited, obviously, to partner closely with Mosaic as they're building better and better models. The last hard part is monitoring. It's similar to when you're evaluating. You know, these models are, in your application, are giving answers to people, and you hope that they're mostly right. But you need to really keep a close eye on them for any serious application. I think you heard the speaker from JP Morgan say, hey, we really need to be sure that this is safe and effective before we deploy it. And the only way to do that is to set up really, really high-quality monitoring. In our view, monitoring for ML models basically becomes a data problem. What I mean by that is, for one thing, you need to log and analyze every response that the model is giving to your customers. You need to correlate your model with end-to-end metrics that you're optimizing for. For instance, if you're doing a customer support model, what are you really trying to do? You're trying to optimize a few things. You're trying to avoid escalation to a human. You know, whenever I get super mad, I just say, please, I want to talk to a person, right? You want that to happen as little as possible in your customer support model. So that's actually a metric you can track. You also want to track things like thumbs up, thumbs down on the answers that the model is generating. Those become data problems, and they feed into a data pipeline that in Databricks can power a monitoring dashboard with a feature we call Lakehouse monitoring. OK, So just to wrap it up, I know I said a lot, but if you take away one thing, it should be that to build real LLM applications, you need to focus on your data. You need to focus on your data for preparing data sets, for building models, and for monitoring and serving. And at Databricks, we believe the Lakehouse platform is the right way to do that. So I'm super excited to work with the next 1,000 customers on AI-driven applications. And to give a little bit of a flavor of what these applications look like, I'm going to invite my colleague, Casey Ulenuth, who's my product manager counterpart at Databricks, and she's going to actually give a demo of building apps on Lakehouse AI. So thank you very much.
We almost made it. Just let me log in real quick. All right. So for this demo, we're going to imagine we're the customer support team, and we're getting inundated with questions about all of our hot new releases on our open source projects. We're getting so many questions, we want to build our own customer support bot to answer all the most commonly asked questions. To do this, we're going to need to first check large SAS models. Large SAS models have an incredible amount of knowledge. But even our customers have run into the limitations here when it comes to data recency and the recency of those updates and the data these models have access to. If you look here, you can see that ChatGPT 3.5 doesn't give us a very helpful response to what is Spark Connect, a technology that we released a year ago. So our team's going to need to build a custom support bot. And we're going to need an AI platform to do this. Luckily, we have the Lakehouse AI platform. The Lakehouse AI platform is going to provide 3 ways for us to build a custom bot. The first is vector search, which is going to allow us to return relevant responses. The second is Lakehouse monitoring, which is going to allow us to monitor the quality of our AI application when it's in production. And then third is GPU serving for large language models, which is going to allow us to have fully customizable models with data security and at low latencies. So let's go ahead and dive in. The first thing we need to do is make sure this customer support bot can answer questions related to recent topics, like what is Spark Connect? Luckily, our team has a ton of documentation on this. We have documentation on all of these new features. And we just need to use that documentation to sort of help our bot along. This is where Databricks Vector Search comes in. Databricks Vector Search makes it super easy for you to index your domain-specific documents. Once you create this index, you can then use it to retrieve the most relevant documents for your whatever question is asked. So let's see this in action. Here I am in Databricks. I'm just going to initialize my vector search client. And then now I'm going to create my index. Creating an index is just a one-line API call. All I have to do is give it an index name, and then 2 things. I'm going to give it my UC Delta table that contains all of my document chunks, and then I'm going to give it the endpoint to my embedding model. That's it. Now, because the Lakehouse AI platform is data-centric, we're going to do a couple things for you automatically. The first is, for this Delta table, any changes that come in, so as new documents come in and you chunk them, we're going to automatically sync that with the index for you. As well as we have a tight integration with model serving, so we're going to automatically embed your queries and chunks in real time. You don't have to worry about all of that. Vector search has you covered. So now let's go ahead, run this cell. You can now see we've created our index. And then now let's see how vector search really works. Vector search is going to allow us to do similarity search in here, where you're going to see I'm going to ask it a question and tell it the number of relevant documents I want it to return. So let's go ahead and run this. And then I just have this cell to actually display them. You can see it's returning 4 chunks. And if I come to the top chunk, you can see, hopefully it's zoomed in enough for the people in the back, you can see that the first document I returned a chunk from is this Spark Connect overview, which seems extremely relevant when I'm asking it what is Spark Connect. And if we actually look at the data chunk itself, we can see that it's explaining how Spark Connect works. Seems like this could have some promising results, but how does vector search work in practice? I'm going to use the new MLFlow Evaluation API that's been extended to work with large language models to actually compare a vector index prompted OpenAI model versus just a generalized OpenAI model. So that's what you can see here is I have these two models. One's generalized, one is the custom model, so we pin that so it's first. That's going to be that vector prompted one that we just built, that vector database, as well as the generalized OpenAI one. So we're going to click to this evaluation tab. We're now going to select our evaluation results. And when we do this, and I zoom in over here, you're now going to see that we're going to have a side-by-side comparison of our model outputs to see how they're performing. You're going to see the custom model, so the vector index prompted one is on the left. The generalized model is on the right. So you can see initially, the first question is, what is Spark? And so it answered what is Spark correctly, both of them. You can also see the tokens and the latency associated with each response. But now that I'm going to a technology that hasn't been released a while ago, so I'm going to Spark Connect, released last year, we can now see that our custom model using the vector index is responding correctly. So this is saying Spark Connect is a tool that allows remote connectivity to Spark clusters. Correct. If I go over to the generalized model, it's going to be a little hard to tell, but this is actually a hallucination. It's giving the answer to what is a connector, not what is Spark Connect. So now that the MLFlow Evaluation API has allowed me to compare my models against a set of questions, I now have confidence in which is the best model candidate for me to deploy. So I'm going to go ahead and deploy our new model, and I'm going to monitor it with Lakehouse monitoring. I'm going to come over to my dashboards, click into my auto-generated dashboard that Lakehouse monitoring provides for me. Lakehouse monitoring, as Patrick said, is a single solution across data and AI. So it's one way that you can monitor all your data and AI assets. Let me zoom in here for everyone. What Lakehouse monitoring is going to do, it's going to crawl over all your assets. It's going to generate a bunch of quality metrics for you. Again, because we are a data-centric platform, we're going to automatically store all of those quality metrics in Delta tables in your account for you. We're then going to auto-generate a dashboard on top for you to visualize results. And you can also use those Delta tables to generate alerts if things fall below certain quality thresholds. The metrics that we provide out of the box are similar to these, so like latency and toxicity if you're monitoring a large language model. If you give us your ground truth labels, we can do model performance metrics. And we also support custom metrics as well. We'll allow you to visualize your metrics over time. And then all of Lakehouse monitoring is built on top of something that we call an inference table. Inference tables are, again, data-centric approach to machine learning, which is saying we're going to capture all of your incoming requests, all your outgoing responses to your model, unpack them, store them in a Delta table, again, in your account, and then you can use this Delta table as your next training data set. Or you can use it to interactively query and debug a problematic response or any performance problems that you're having. The last thing you'll probably notice down here is there's this PII graph. We've extended Lakehouse monitoring to support PII detection. Now, where this comes in handy is I don't expect this customer support bot to have any sensitive data in it. But it turns out some of our customers are putting in sensitive data in their questions to our bot. And this is a problem because we have compliance standards we have to meet, and we can't actually leak any sensitive data to third parties. So we're going to need to replace the OpenAI model with a private model. Databricks curates a set of best-in-class open source models for us in the marketplace. We can then load any of those models into the Unity catalog where you can use them across your organization. Once you have one of those models, you need to now deploy it as an API. And this is where Databricks model serving comes in. Databricks model serving is a low latency, highly available model serving solution, and we've abstracted away all the complexities of the infrastructure from you. I've gone ahead in here, and I've already deployed MPT30B, which is the recent release model, on a Databricks model endpoint. In here, you can see it's using the new GPU model serving, so it's configured with GPUs. And then you may have noticed this purple icon. This purple icon is letting me know that this endpoint is optimized. Again, for those curated set of models in the marketplace, we have optimized our solutions, including model serving, to give you better performance. And in fact, with model serving, we've seen customers get up to an order of magnitude better performance with these optimizations. Now that I've got this model deployed, we're now going to swap our MPT model with OpenAI so we can have that data security and we have our fully customizable model. So now if I go back to my dashboard, I'm now going to have it grab all the data up through today when I deployed it. And so now when I change my time window of my monitoring solution, I can come down and you can see on my latency graph that now we're getting much better performance that we've hosted the model ourselves. This is just an example of what you can achieve with Lakehouse AI, and these are just 3 of the features that we've provided. So again, we showed vector search so that you can get relevant responses. We showed Lakehouse monitoring so that you can monitor the quality of your AI applications. And lastly, we showed that you have GPU serving optimized for large language models so that you can get amazing performance and data security. Those are just a handful of all the releases that we've made as an AI platform this week. But we just want to give you a sample of that, and we're very excited and cannot wait to see what you all build with it. With that, thank you, and I'm very excited to bring onto stage Sai from JetBlue, who's going to walk us through how his team has leveraged the Lakehouse AI platform to build large language models. Thanks.